Okay? You can make all kinds of predictions with them, future populations. Notice that several of these things, future population of bacteria, that's not even physics or math. That's
Isn't that been done
biology.
before?
What?
Haven't we done? Like, isn't that just an exponential equation? Or does it get
It get you can do a lot better job than those. Okay. You've done some very basic models. These allow you to predict a lot of other things. Okay. So yes, you have done some things along these. We did some differential equations. We separated variables last year, right? We had dy dx and we'd separate the dy and the dx and integrate. That's what today is. Okay. Next week we will get into some that you can't separate. Okay. And then we'll get into some where you might be doing them separately for dy and dx. They'll be more like parametric, where you have dx dt and dy dt. And that's where you need eigenvectors and eigenvalues. And then we'll start doing the part that I'm still not sure I understand, which is phase diagrams, where you have to sketch kind of paths that things take based on differential equations. And I can tell you how to do several parts, but I'm not sure I fully understand it. Okay? So if you get a phase diagram, it's one of those that you take your best guess and you move on because you don't have time to linger and don't miss other points that you could get by trying to earn a point on a diagram that you probably won't get right anyways. Or don't miss 10 points to try to earn one. So the answer to all of these questions is through differential equations. Concept. Through this section, we will be expanding your understanding of differential and integral calculus to solve problems related to science and mathematics involving derivatives and rates of change. Just as you solved related rate problems, you will now solve more complex problems through more advanced techniques. As you go through this chapter, I'm out right now. You may borrow my calculator, and I will plug it in later. What's charging? Those are physics cards.
at least one?
Physics cards. Um, it graphs the velocity, the acceleration, and the position of the cart as you move it along the track. Your TOK connection. Your goal throughout this course has been to get the right answer. Did it ever occur to you that mathematics may be unique in all areas of knowledge in that regard? Is there a right answer in history, art, human sciences? Consider the methodology by which areas of knowledge establish validity of knowledge. What is unique about the methodology of mathematics that allows for such certainty? We will be exploring that in TOK class in like 2 months. Kind of wish we could do TOK first. First order differential equations. Okay, so you've seen differential equations like this last year. Um, you couldn't actually integrate that, but you could replace e to the x squared with y. And this is where we will be going eventually, sort of, with coupled differential equations. There's some terminology in this section that you need to learn. Okay. What's called a partial derivative or a partial differential equation? So right now we have a function of x and y here. This f of x, y. The partial derivative means all I'm taking the derivative of is x, and I'm leaving y as if it was a constant. That's a delta. It's capital delta. So I would probably write it as df dx. And what am I doing the derivative of? Just the x part. So the x squared becomes a 2x. Y just stays as a constant. Because y is a constant, I can ignore its
It's what?
the fact that it's a product rule otherwise.
Why does their answer not include the plus 2y down below?
So what's the oh, because it's a constant. Sorry, I missed that. The derivative of a constant, derivative of 2 or 7 is 0.
But I thought we didn't do it.
We do the derivative of the whole thing. We treat y as if it's a constant.
Okay.
So in this case, it would just be 2x y.
2xy, yep, plus 0.
I see.
We So the next one here is with x being the constant. So we've got constant times y is x squared. Derivative of 2y is 2. Does that kind of make sense? So this was not a y equals like we would do implicit. Y equals x squared y plus 2y. This was a function of x and y. So that would show up like on a 3D graph. Z of x, y.
Okay, wait, what just happened with the df dy?
We treated y as our variable and x as a constant. So derivative of constant y is just the constant, which is x squared. Derivative of 2y is 2.
The wording, the left of the delta of delta y was the end product of the blood spreading on Sunday.
Yeah, it's the original problem. So otherwise it'd be 0. The second derivative, d squared f dy squared would be 0. Does that kind of make sense? For the first one. Now this is the derivative. So I'm making y a constant. Let's put it as a 2. Now we'll make it a 4. Let's do this in another color. So I'm looking at this and treating it like it's for when I'm deriving for x. So this would be 4x squared plus 8. And I do this derivative with respect to x. X is my independent variable. We get 8x plus 0. Well, y is 4, so 2 times 4x is 8x. So my independent variable's x, right? That means everything else here is a constant. So it's like yx squared. Bring the 2 in front. With constants, you bring the 2 in front and multiply. Reduce the power by 1.
But then how do you get?
The second one? So now mine is y. Y is my variable. So x squared is my constant. I bring the 1 in front. Leave the x squared alone. Y to the 0. I have 2y. The derivative of 2y is 2. Mm-hmm. Are you guys following? Izzy, you following? It's like you're in Calc 2. That probably helps. This partial derivatives and partial integral stuff is multivariable calc, which is three-dimensional. Now, one of the tricks to that is you'll treat all variables except one as a constant a lot of times. No, we've got bus evacuations. Yes, of all days.
What time?
8:40 till probably 9, depends when we get called. It'll be just what it is. Okay.
Yeah.
No. So, okay, let's do. However, we only deal with ordinary differential equations. Some examples of ordinary differential equations include these.
What? What's an ordinary differential equation?
One that you can actually solve.
But not the partial, correct?
The partial stuff is easier. The partial stuff is easier than some of these.
Don't have to.
You only have to account for one variable at a time. But you have to remember to leave the other one as if it's a constant. Yeah, don't do implicit. If if it gives you this notation, that's partial. We are going to, so they're using the delta like it's a D, but for partial. Okay. We're not going through how to solve these ones yet. You're just looking at terminology and learning names. Okay? This is a first order differential equation. Do you know why it is a first order versus second order at the bottom?
dy dx and it's.
This is first derivative.
Yeah.
That's a second derivative. This is a first derivative squared. This is not that. They are not the same thing.
Or that's it.
So yes, this is a d squared y. You wonder why they notate it like that? Because this is dy dx times dy dx. It's just two first derivatives times each other.
Next, what?
This one here.
Oh, okay. So that
Square.
would just be dy squared over dx squared, whereas.
Mhm.
Second one is just.
And there's a reason we don't ever notate it like that because it's too similar. Okay? They're too similar. We don't want to notate it like that and make it more confusing than it already is. Because this is like a velocity, right? So if I have y,
Won't be your second hour, it's less fast.
Okay.
And so, probably not at all.
Okay. Thanks for the heads up.
I mean, I won't be fit, I mean, we're back in school.
Okay. Figure it out. He's got to help another class. It, it's fine. Pre-calc's testing. Physics is doing a lab. It's fine. It'll be fine. So if you thought of this as position, this would be if let's call y position for this case. This is v squared, right? This is acceleration. Those are different concepts. Okay. That makes sense. So that's why we have to have this notation differently. Okay. Here's some new notation that it's time to introduce you to. Which, again, this is dy dx. Y dot means y prime, yeah. But they're using it? Yep. Um, I think the primes is the American notation. I think the dots is the international notation. You can use either on your exam, but you need to be able to read both because they will use both depending on who wrote the question. Well, some of these questions are written by British. Some of them are written by Americans. Some of them are written by Canadians. Some of them are written. So, so they do, but you get people, you can submit questions from different teachers can say, hey, here's a good question for an exam. And then and it's from all over the world. I kind of wish, honestly, we're the Americans, we're the oddballs out on a lot of these things. I like ours is easier to type. Probably, our keyboard has that on it. But other languages have things like that anyways in there. So there are ways to type it. We just don't have them in America. Okay, so does that make sense? First order linear differential equation. Linearity?
Under the,
I'm trying to figure out what ODE means. Ordinary differential equation. First order non-linear means line. First order nonlinear, it's nonlinear because of the sine x.
Oh.
Second order linear, I don't see anything that's not linear here. Second order nonlinear has the cosine. Third order, you won't have to do any third orders in this class. I'm interesting that an ln x is there in linear. Then it's second, yep. If it has a second derivative, it's second order. If it has a third derivative, it's third order. Okay. Regardless, it's like cubic polynomials can have squareds and firsts and constants and things. So we have made it through 14.1. Yeah, all it is terminology and classifying. No, 14.2 is separable. Okay. Which we've done. We did last year. 15.5, 5.15. 5.15 is going to be slope fields and isoclines, which are related to slope fields, but not on the exam. The book puts them in here because it thinks the understanding will help you with the further problems. It thinks it's going to be having an understanding of those will make phase diagrams easier. Today. 5.14 isn't that bad. And honestly, the cognitive problems on some of these aren't that bad. And actually, the differential equations problems on the IB exam last year, I think I know how to do all of them. Okay. This goes way down a deep rabbit hole. The actual questions they're putting on the exams aren't as deep down the rabbit hole as you can go. Some of my practice problems are way worse than what's on the exam. So you might get a little buried the next few weeks by problems. The stuff I've seen on the exams isn't as bad. Okay, separation of variables. We did this last year, so I'm going to skip to the example. So, yeah, all they're doing. Okay. They are sometimes, instead of notating dy dx, they're calling it y prime. I recommend, for separation of variables purposes, calling it dy dx. So because dx is on the bottom, I'm going to move x to the right side and y to the left. I pretty much always do that. But to start with, to move at, I'm going to multiply both sides by x and both sides by y. So it's like those are multiplied by the top. What does that do? Cancels the x's, cancels the y's. Gives me y dy dx equals x e to the x. Now I will multiply both sides by dx. And get integral of y dy. Well, I guess I don't have the integral yet. But y dy equals x e to the x dx. Now I could integrate, correct? If I'm going to integrate, I have to do it to both sides. That makes sense so far. Can I clear?
Wait, so once.
Okay, I'll write the next one up above.
Okay, I'm good now.
dy dx equals cosine squared x cosine squared y. Yeah, we're not integrating these. Yes,
It's like, do not.
new problem. I just wrote the new problem while I was waiting for people to finish. So I will multiply both sides by dx, and you okay with me writing this out in one step? And then divide both sides by cosine squared y? Is that okay? You can write it in two if you want.
No.
It's forbidden.
So I was gonna get the y
We want to get the y with the dy and the dx with the x on opposite sides of the equation. And you didn't know how to integrate the x e to the x. Your calculator, however, does. So you could do a definite integral on it. So it wouldn't ask you how to do that. It's integration by parts. I will teach you that after the IB exam.
Yeah, I don't do.
You do not need it for the IB exam, but you do need it for Calc 2. And so cosine squared here is secant squared, which what's the integral of secant squared? Tangent. See why I changed it? Cosine squared. I think you did that one the other day as one of your integrals and used an identity. I think that was one of the ones at the end of your review. I think it was 6.1. I think there's an identity and you didn't even need to use U substitution. Okay, 3 is gonna be a little rough to separate. Can I clear? X. I'm gonna leave it as y prime and start separating x and y first. And I'll make it dy dx in my next step. So I want to divide both sides by x, correct?
Oh, I'm looking at the wrong one.
You're looking at 4?
Yeah.
4's got some trick to it. 4 is the kind that I sometimes miss the trick. But I think I'm getting better at it because you didn't have to do that trick really in AP. So now I'm going to change my y prime to do dy dx. Now I'll multiply both sides by dx. And for the heck of it, I'm going to integrate this. Because I want to see who remembers how.
It's.
Oh, actually, you don't know how to integrate L and Y.
So.
You need integration by parts for that. But this one, what would your U be on this one? Ln x du is 1 over x. So it's u du. It's just the integral of u du. Ln y, you don't know how to integrate, that's integration by parts. Izzy, you know by parts, don't you? U is ln y, dv is dy. V is y. Du is 1 over y. And then you have to plug into the formula. That is uv minus integral of v du. It's not so bad once you get it, but I don't need to clog your brains with that. There's enough other things. We good with that one?
Yeah.
Okay, this last one. First thing I'm going to do is divide by this.
Square root on the other side.
I do, yes, thank you. I would have caught it in the next step.
I'm sorry.
My brain is a little scatterbrained like that sometimes. Now I'm going to move so I can't move just the y squared, but I can move a 1 plus y squared. And that's one of the tricks. Sometimes you can't move a y, but you can move a whole factor with other constants involved. That is something we didn't do last year. Because I need y on the left side. Now I'm just going to move my dx. And yes, you should show all of this because you might get 2 points for separating variables on an IB exam, even if you can't complete the integration. Okay.
So we're not doing the integration just at the same time, right?
Some of them we can't integrate. There will be some that we get to where we integrate.
How do we know if we can do it?
How do you know if you can't? It won't ask you to if you can't. Or it'll give you bounds, or it'll give you a situation where it want you to separate the variables, and then it'll give you some bounds and you'll do it with your calculator.
So one side.
What?
the other one.
No.
You were not doing limits at infinity, no.
Oh,
We saw from the other manuals, you just think. I don't know what the ratings.
I don't know. Sometimes I don't agree with the difficulty of the ranking system.
We really think that was your most helpful?
The one that I just did? No. So determine whether this is separable. So I can easily multiply both sides by dx, right? Oops. And please, please, please do not forget parentheses. I could always distribute, but I need to get y to the other side without moving a dx. So I could now subtract y dx, but I can't have dx over here. This is not a separable differential equation. I cannot get my y dx, my y over to the left side without having a dx over there.
Can't we just divide by y?
I have to divide both parts by y. You cannot divide half of a side. You should divide everything on that side by y. So if I want to divide by y,
Not just linear.
then I have to divide this by y, and I haven't moved all the y's. Not separated. Not separable. Doesn't matter how much I want it to be separable, it's not. Okay? And you can thank me for working that out and showing you, because the book just tells you it's not. This one. Let's see. What do you guys think? I can multiply by dx, right? The question is, can I bring my y over?
Yes.
You can divide by y squared. And it wants me to find the full solution, so I need to go all the way here on this one. So I'm going to bleed into example 4's space. And now I will integrate.
Oh, actually,
So this is like y to the negative second, right? And I add 1 to the power and divide by the new power. What am I missing?
oh, L plus C.
Plus c. And I only need to put the plus c on one side because I could just combine them into a new c.
Then wouldn't it be two C? No.
So I don't know what c is. So I can change 2c to 2x, 2l, or 2v, or I can have c1 and c2 and change them both to a c. Y to the negative second is 1 over y squared. So that's how I integrated. No. I'm just giving this little reminder that that's what I'm actually integrating. I just didn't feel like writing a whole nother line. So the general solution, I now need to, okay, so this is 1 over y. The general solution has to be in y equals form. Which means I kind of can take the reciprocal. Um, but I'm going to go through like actually solving. I'm going to multiply both sides by y. It is negative. Thank you. So this is a -1. And then I will multiply both sides by the reciprocal. I'm going to put the c on top. They've been calling it C1 here and changing that to a C. Okay, yes, it's half as much, but I don't know what C is yet anyways, so I don't care. Multiplying by 1 over that is the same as multiplying by its reciprocal.
So this is -1 over x squared.
No, it's the reciprocal of this. It's 1 over that. And I just combined the C's so I could make it a single fraction so I could flip it.
Does two divide C as well? Or C divided by two as well?
So I don't know what the constant is. If it was 4, if I want to put it over 2, I just make it 8. I don't know what it is yet, so I can just I can kind of fudge the lines. That's why they're calling it C1 and then changing it to C. I'm kind of like, it's just C. You can fudge the lines because you don't know what it is. And if it was 4 when it was here, it's now 8 when it's over 2. So I end up with equals y.
How solve you that one?
I don't know. Doesn't say. That one wasn't that bad. This next one's worse. So now I've got two y primes. It's not really that much worse though. So I'm going to add y prime to both sides and y. So I'm swapping the sides. That makes sense? So I'm getting the y primes together. Those cancel and these two cancel. Does that make sense so far? What can I do with the xy prime plus y prime? Factor? We good so far?
Yep.
I don't think I don't.
So I added y, which moved to both sides up here, which moved it to there. I added y prime to both sides, which moved it here, and then I factored out a y prime. That's just a lot of mess with all of that written there. So I'm just rearranging, lots of algebra. Now I shall divide by x plus 1 and get dy dx equals 1 plus y over x plus 1. Now I think I shall multiply by 1 over, I'm going to call it y plus 1 instead of 1 plus y because I like that better. It makes more sense in my brain and it's mathematically the same. And final step, I multiply both sides by dx. Well, I guess not final step. Now I got to integrate. Okay. Now I will raise both sides to the power of e. And we did this last year. Well, I've got a plus c up here. Yes. Yes. Give me a minute, guys. I'll finish this one problem. So remember last year our rules of exponents said plus c means e to the c, which is just a constant. We brought it in front, called it a. And this is me just going, it's a constant. E to the ln y is y plus 1. E to the ln x is just x plus 1. And I'm going to subtract 1. Okay. The general solution still has this a in it or the c in it. The particular solution does not have the c in it. It says y of 1 equals -2. So now I just And if you're doing these on the test, putting in the plus C is worth a point. For getting the plus C, you kind of lose the rest of it because you can't find the particular solution. So now I just solve this. Why? Oh, wait, no. I did that wrong. Y is negative 2, X is 1. Yeah, Y is negative 2. So now I've got 2A minus 1 equals negative 2. Negative 1/2 equals A.
What'd you get two in?
1 plus 1 is 2. Welcome to differential equations. Okay, that is not done. I am not done. My particular solution is this, and you have to write out that. Do not, you lose a point if you don't actually fill in A and write the solution.